Alright, so in this video we're going to be solving equations where we find all solutions. Because of the periodic nature of our trigonometric functions, all solutions is usually an infinite number of solutions. Alright, so let's start with our first equation here. So I want to find, so in this example, find all solutions to the equation cosine of x is equal to root 2 over 2. All right. So again, right, our function is periodic. So I know that the cosine is positive in quadrant 1 and in quadrant 4. Right, so the solutions is this angle here and this angle over here. Right, but not only those, right? Any coterminal angle there, right? So any here, if I go 2 pi radians in the positive direction, that's also a solution. But if I go 2 pi radians in the negative direction, that's also a solution. Right, so every integer multiple of 2 pi, right? So 2 pi, right, 4 pi, 6 pi, etc. Right, and the negative ones as well. Right, now how do I represent that, right? Well, I'm going to have two values for two equations, excuse me. Right, when x is equal to, right, the value here, this angle here, x would be pi over 4. That's a solution. Right? Now, how do I capture every multiple there? Well, since it's periodic, the period is 2 pi, we would have 2 pi k, right? Now, when I write something like this, I have to be very careful here, right? K is representing an integer, right? So values like 1, 2, 3, 0, -1, -2, -3. I have to be explicit about that, right? So I have to make sure I say, all right, where k is any integer. Right, so when k is 1, 2 pi, that would be, let's see, what, 8 pi over 8, that would be 9 pi over 4, right? That would be here, and then the corresponding 9 pi over 4, right? So it'll capture every 2 pi revolutions, you get another solution, similar to that graph that we had in the intro, right? But that's just this angle in quadrant 1, right? In quadrant 2, we have 7 pi over 4. Right, that would be this angle here, but also every angle that is coterminal with that angle. Right, so again, it'll be coterminal at every multiple of 2 pi, right? Every integer multiple, right? Again, k is element of the integers. Excuse me, I didn't explain what this was. K is an integer. What we see here is k is an element. That's what this little fancy e is. And z is what mathematicians call the set of all integers. Right? So if you explicitly write this out, k is an integer, that works. Or if you write this more mathematical notation, k is an element of z. All right? But you have to explicitly say that. If you just write k, right, k can be any number, which is not true, right? It has to be an integer, right? And you must explicitly state that. Right? And that's how you would find all solutions. Right? Now this is our very basic function here, where we just have x. Now what if we had some kind of composition of function in our trig function, right? So what I mean by that is, well, let's say that we change it up a bit, and what if we had sine of 2x is equal to -1/2. Okay, so again, this is in our unit circle. So here, think of this as this whole thing, 2x, as our angle theta, right? The angle theta is equal to -1/2. All right. Okay, so if we do that, you can say, when is the sign negative? This happens in quadrants 3 and 4, right? So here, this is one angle, right? I call this one theta 1. And then this angle over here, right? I'll call this here theta 2. Okay, and again, because of the periodic nature of the sign, right? Any coterminal angle is also a solution, right? And the way we find those coterminal angles is 2 pi factors, right? Whether in the positive or in the negative direction. All right, so for theta 1, we get 7 pi over 6, that's our angle in the third quadrant, plus 2 pi k. And for theta 2, we get 11 pi over 6, plus 2 pi k. Right, and again, don't forget k is some integer. All right, but I'm not asking for theta 1, I'm asking for solving for x, right? So theta 1 and theta 2 are going to be replaced by this 2x. All right, so instead of theta 1, I'm now going to write 2x is equal to 7 pi over 6 plus 2 pi k. All right, and I want to solve for x, so the way I solve for x here is I don't want 2x, I simply want x, so I just divide by 2. And divide, in this case, both of these terms by 2, right? 7 pi over 6 gets divided by 2. 2 pi over k gets divided by 2. So simplifying, here we get this simplifies to 1. We get x. 7 pi over 6 divided by 2 gives me 7 pi over 12. And here 2 pi k divided by 2, those 2's will reduce to 1. You get pi k. Okay. And again, k element of z, right? The integers. Okay, so that's one of the solutions, the equations of the solution, right? This represents an infinite number of solutions, right? K can be 1, 2, 3, negative 5,000, right? It could be any of those values there. Now, for the other equation, 2x will equal to 11 pi over 6 plus 2 pi k. Now divide through by 2. X is 11 pi over 12 plus pi k. Okay. All right, and again, I did the same thing here. I got ahead of myself here. I divided by 2 and divided this by 2 here. All right, so now we have our solutions here, are these two equations, right? Now, these two equations, it's not two solutions, right? These two equations are representing an infinite number of solutions. Okay. All right. Let's go ahead. Let's try another example here. Here I'm going to try use a tangent. So for this example, I want to find all solutions to the problem tangent of x is equal to negative root 3. Okay, so we have a composition in the argument for tangent. So we'll approach it like we did the previous example. Right? Negative root 3, that's a value that is on our unit circle. One thing that is going to be different here than the previous ones, the previous sine and cosine equations, is the period of the tangent is pi. Right? So when we look for solutions, right, it is enough to look for solutions that fall between 0 and pi. And then every other solution is just a factor of pi k that gets added to it. Right? So for example, here we're looking for values of the tangent that are negative. Right? So our theta would be here. All right, now it's also in quadrant 4, but we can get to quadrant 4 by just adding pi. Right? So if we add pi, gets us here, add another pi, gets us here. Right? So when dealing with tangent and cotangent, right, it's simply enough to find solutions in our interval 0 to pi. Right? And since the period is pi, we just tack on a factor, we add on a factor of that pi k. Okay, so in this case, our theta, that angle is going to be 2 pi over 3. So to set up our equation, you get 2 pi over 3 plus pi k, right? Major difference from our cosine and our sine because of the periodic nature of tangent, where the period becomes pi and it's not 2 pi. All right? And that's the only time the tangent is negative, between 0 and pi. Okay, to get to the one in quadrant 4, we'll just add in pi. So this captures all of it, right? We just have one nice equation here. But again, I'm not looking for k is an integer. I'm not looking for theta. I want to solve for x, so I'll replace theta with x over 2. That is equal to 2 pi over 3 plus pi k. Okay, and then here, all right, I want to solve for x. I don't want x over 2. I want x. Since I'm dividing by 2, the reciprocal operation here is to multiply by 2. All right, so I'm going to multiply. Here, that reduces to 1, so I get x. Over here, do not forget to distribute. Here, so here we'll have 4 pi over 3, and here we'll have plus 2 pi k, where k is any integer. All right, and that's how we find these problems, or excuse me, these solutions. All right, let's do one more example here. This one will involve a cosecant. So for this example, I would like to find all solutions to the equation cosecant 1/3 x minus pi equals to root 2. Okay. All right. So I'm going to approach this here. All right. Again, I'll look at cosecant of theta, right? I'll just let this composition here of the argument of cosecant, I'll just call it theta for now. I'll introduce the x back a little later. When is that equal to root 2? Again, this is equivalent using our reciprocal identities of the sine of theta equaling root 2 over 2. Okay, so we're looking for values of the sine that are positive, and that happens in quadrant 1 and in quadrant 2. Right. This is on our unit circle. This corresponds to pi over 4, one of our thetas, and the other theta is 3 pi over 4. Okay? All right. So here we'll have our two equations. We got theta is equal to pi over 4 plus 2 pi k, and theta equals to 3 pi over 4 plus 2 pi k, or again, k is an integer. Okay. All right, so now I found my initial here equations, but they're not in terms of x, they're just theta. So let's substitute here our composition that we have out here. So we're going to have 1/3 x. Now 1/3 x can also be written as x over 3 minus pi. All right, so I'll replace that with our theta here is equal to pi over 4 plus 2 pi k. Okay, so now we'll use techniques to solve equations here. I want to isolate the x. I do that first by adding pi to both sides. Okay. All right, now here when we divide the whole thing, but when we're adding, we're just going to add the like terms, which are these two here. All right, remember here fractions, pi over 4 plus pi, that's the same as saying pi over 4 plus 4 pi over 4, right? Common denominator. So our equation becomes this is 0. You get x over 3 plus 5 pi, or excuse me, not plus, equals 5 pi over 4 plus 2 pi k. All right. And then the last step here, again, to isolate x would be to multiply both sides by 3. And again, don't forget to distribute here. So we get x, 3 times 5 is 15 pi over 4. And 3 times 2 pi k is 6 pi k. All right, where k is an integer. And that is one equation, right, that represents an infinite number of solutions. Okay, now let's work on the other one here. I'm going to get a fresh sheet of paper here. Okay, so our other equation, so we have x over 3 minus pi equals to 3 pi over 4. Plus 2 pi k. Okay, and again here, from here is just some algebra work here. We're going to add pi to both sides. Right, again, watch common denominator 4, so this is 4 pi over 4. So here we have this zeros out, and we get x over 3 equals to 7 pi over 4. Plus 2 pi k. All right, and now multiply both sides by 3. So this gives me x. This here is 21 pi over 4 plus 6 pi k. And let me just rewrite the other equation here. And in both cases, k is some integer. Okay, and that is how we find all the solutions to this particular equation. All right, in the next module, we'll take a look at, all right, how do we use, or in the next video in this same module, we'll look at, all right, what if I have a given interval? All right, I don't need all the solutions. I just want the solutions that are in a given interval. Okay, and we'll take a look at that.